So for question number 1, a crate of mass 500 kilograms is being pulled along rough horizontal ground by a horizontal rope attached to the winch. The winch produces a constant pulling force of 2500 Newton and the crate is moving at constant speed. Find the coefficient of friction between the crate and the ground. Okay, so this is the free body diagram of the situation that we have right now. So they want us to find the coefficient of friction. So now, since this crate is being pulled at constant speed, the FMA for this situation will be 2500 minus our friction force equals 0. Okay, so why 0? Because our MA, the A is 0, right? Since this is a constant speed problem. So since our A is 0, our MA will be 0 as well, okay? Giving us our friction force to be 2500 Newton as well, okay? So since we already know what is the friction force acting on this crate, okay? The formula for friction force is equal to mu n, or you can also say mu r, okay, depending on whether you will call this normal force or reaction force, okay? So how to get the normal force or reaction force? It will just be the what we call it, the opposite of what this 500 kg is acting, okay? So this 500 kg, the force that is acting downwards is 5000 Newton, and so the normal force or the reaction force will also be 5000 Newton, okay? So then, since we already have our friction force, which is 2500, so our normal force is 5000. Finally, our coefficient of friction of the ground is 0.5, and that's all for question number 1. Let's look at question number 4. A particle of mass 20 kg is on a rough plane inclined at an angle of 30 degrees to the horizontal. A force of magnitude 25 Newton, acting at an angle of 20 degrees above a line of greater slope of the plane, is used to prevent the particle from sliding down the plane. The coefficient of friction between the particle and the plane is mu. For part A, complete the diagram below to show all the forces acting on the particle. Okay, so since we cannot show it on this question paper, we have it on the blackboard here. Okay, so the first one is the force that is acting into the plane. Okay, this will be mg cos 30 degrees. Okay, so what will happen with this mg cos 30 degrees? We will have something which is going out, okay, or we can say that is the normal force, or you can also call it the reaction force, okay, but I'm going to call it normal force. Okay, the normal force will be acting on this particle, and this normal force can increase or decrease based on the direction of this 25 Newton force, okay, but that's later, okay. So the next thing is the particle will be pulled up, okay, pulled up the plane by this 25 Newton, but it's not the 25 Newton, it will be the 25 what we call it, cos 20, okay. Alright, 25 cos 20. And then the opposite, or the force that will make the particle slides down the plane, that will be mg sine 30 degrees, okay. Okay, and then the remaining thing here will be the friction. Okay, so this is how you can determine the direction of the friction. Okay, so since they said, okay, the force 25 Newton is being used to prevent the particle from sliding down the plane, meaning that the particle is about to slide down. Okay, so if the particle is about to slide down, so you know that the friction, okay, is one of the forces that will be used to prevent that from happening. So in this case, your friction force will be acting up the plane, okay, or going up the plane. Okay, so let's say if the question is the other way around, let's say the particle is about to go up the plane, then your frictional force will be acting downwards, same direction with mg sine 30 degrees, okay. So this will be all the forces acting on the particle, and that's all for question number 4, part A. And for part B, find the least possible value of mu, alright. So for us to know what's the, what we call it, least possible value of mu, we need to construct the FMA equation first, or the Newton's second law of motion equation, okay. So as we have here in the diagram the direction of the forces. Okay, so we can see that 25 cos 20 and the frictional force will be in the same direction. So we will have 25 cos 20 degrees, okay, and then plus frictional force minus the mg sine 30 degrees. Okay, so your m will be 20 kilograms, okay, and your g is 10 sine 30 degrees, okay, equals 0. Okay, so y 0 again used to prevent the particle from sliding down the plane. So it is about to slide down the plane, but it is not sliding yet. Okay, so the acceleration will be 0. So the frictional force will then be 200 times 0.5, okay, since sine 30 is 0.5, minus 25 cos 20 degrees. So we know that 200 times 0.5, that will be 100, right? Okay, so 100 minus 25 cos 20, so that will be 76.51 Newton, okay, for our frictional force. Okay, so next we know that for frictional force the formula will be mu n, okay, or some of you will be using r, okay. Mu r is possible as well. Okay, so we need to find our mu. So before that we need to find our normal force. Okay, so 76.51 equals mu. Okay, so how to get the normal force? Okay, let's refer to the diagram again. As you can see, for our normal force, mg cos 30 is acting into the plane and the normal force is acting out of the plane. And be careful of the 25 Newton. As you can see, this 25 Newton also have a component which is going out of the plane. So meaning that your n will be, okay, let's write the equation of n. Okay, so n, okay, plus 25 cos 20, since they are in the same direction. Oh, sorry, it's not cos, it's sine, okay? Because just now we used the cos to get the force which is making the particle go up the plane. So what we call it, the other force will be 25 sine 20 degrees equals mg cos 30, okay? Okay, this is just as a side note, okay? Alright, so your n will then be mg cos 30, so that will be 200 cos 30, okay, and then minus 25 sine 20, okay, so that will be 164.65, okay, Newton, okay. So now we are going to replace this inside, so 164.65. So finally your final answer for mu will be 75.61 divided by answer, you will get 0.459, okay. So this will be the final answer for question number 4, part B. Next, for question number 2, a particle P of mass 0.4 kg is on a rough horizontal floor. The coefficient of friction between P and the floor is mu. A force of magnitude 3 Newton is applied to P upwards at an angle alpha above the horizontal, where tan alpha equals 3/4. The particle is initially at rest and accelerates at 2 meters per second squared. For part A, find the time it takes for P to travel a distance of 1.44 meters from its starting point. Alright, so we try to draw, okay, a sketch of a diagram for the situation that we have for question number 2. So this is what it will look like. Alright, so even though we are not going to use this diagram yet for part A, okay, but we are going to use this diagram for part B later, right? So for part A, we need to find the time it takes for P to travel a distance of 1.44 meters from its starting point. So according to the formula sheet, okay, that we have, so the formula that we can use for this question will be S equals ut plus half at squared. Since we have the distance, we have the initial velocity, we have the acceleration, and we want to find the time, okay? So the distance that we need to travel will be 1.44 meters equal, okay, so since the particle starts from rest, so that means your u will be 0. So 0 plus half of your a, acceleration is 2, and then it will be a t squared. Okay, so you know that 1 over 2 times 2, that will be 1, so leaving us with only t squared equals 1.44. Okay, and finally our value of t will be equal to surd of 1.44, and that will be 1.2 seconds. Okay, so this will be the final answer for question number 2, part A. And next, for part B, find the value of mu, okay, which is the coefficient of friction between the particle P and the rough horizontal flow. Okay, so referring again to the diagram that we have here, so you can see that this will be the applied force of 3 Newton. Okay, so when we want to find this, what we call it, when we want to find the value of mu, you need to also consider the normal force that we have here, okay, or the reaction force. Since we have the weight of this particle P, so we will also have the normal force or the reaction force, okay, because your normal force will affect the frictional force that you have between the particle and the flow. Alright, so we are going to do Newton's second law of motion first. So that will be F equals ma. Okay, so the pulling force, okay, will be contributed by the x direction for this 3 Newton. So that will be, okay, so let's say we draw the triangle here. So we know that tan alpha is 3 over 4, so opposite over adjacent. So you will have for the hypotenuse to be 5. So if we want to find the x component of this 3 Newton, that means you will use 4 over 5 of the 3 Newton. Okay, so that means we will have 4 over 5. Okay, or you can also say something like this first. Okay, so this will be 3 cos alpha. Okay, we'll just write it like this first. Okay, 3 cos alpha, and then minus the frictional force. Okay, since this is what we have other than the pulling force, and then since we don't have any other force, equals with your ma. So your m is 0.4 and your a is 2. Okay, your acceleration is 2 meters per second squared. Okay, so like I said just now, your cos alpha will be 4 over 5. So 3 times 4 over 5 minus your frictional force equals 0.8. So finally your frictional force will be equal to, this will be 1.2. Okay, wait, let me check. So 3 times 4 over 5, you will get 2.4. Okay, so then 2.4 minus 0.8, you will get your frictional force as 1.6 Newton. Alright, so next, after we have found the frictional force, okay, we know that frictional force, the formula will be equal to mu of n. Okay, so this is the normal force that we that I mentioned just now. So equating your frictional force to 1.6 Newton, we can find our value of mu if we know what is the normal force. Okay, so now to find the normal force, you can see that from this diagram, okay, our normal force is this direction, okay, and this is the weight. And please don't forget that the force of 3 Newton also contributed, okay, to the upward force. So that means this will be 3 sine alpha. So your normal force, okay, n plus 3 sine alpha equals w. So that what we are going to write as the component in the y direction, okay, the component of your force in the y direction. So that means we will have normal force plus 3 sine alpha equals w. Okay, so w is the weight of the particle, which is 0.4 times 10. Okay, so normal force plus, okay, so 3 sine alpha, according to this triangle just now, our sine alpha will be 3 over 5. So 3 times 3 over 5 equals 0.4 times 10, that will be 4. And finally, your normal force will be equal to 4 minus 9 over 5, and that will be 2.2 Newton. Okay, so now replacing your 2.2 Newton inside the equation of your frictional force, finally you will get your value of mu as 1.6 divided by answer. You will get a final answer of 0.727. Okay, correct to 3 significant figures. And this will be the final answer for question number 2, part B. Let's look at question number 6. a block of mass 3 kg is initially at rest on a rough horizontal plane. A force of magnitude 6 Newton is applied to the block at an angle of theta above the horizontal, where cos theta equals 24 over 25. The force is applied for a period of 5 seconds, during which time the block moves a distance of 4.5 meters. For part 1, find the magnitude of the frictional force on the block. Okay, so based on this diagram, this will be the situation that we have, okay? And given that cos theta equals 24 over 25, so you should know that in case we need to use sine theta, what is the value of our sine theta, okay? So that will just be 1 minus, in bracket, 24 over 25 squared, okay? And then you square root the value, then you will get 7 over 25 for the value of sine theta, in case we need to use this later in the question. So, denoting this as the direction of our frictional force, okay, since for example, if the block is being pulled to the right, okay, and we have a weight of 30 Newton, okay, due to the mass of the block, and then we will have a reaction force, okay, or normal force. I will call it reaction force in this question. Reaction force acting upwards. And don't forget that this 6 Newton will have its y component as well as its x component. Okay, so now we can start doing this question. So the first thing that we need to find, the first thing that we need to use first, okay, is in a period of 5 seconds, the block moves a distance of 4.5 meters, and we are going to use this to get the acceleration of this block, okay? So our u is 0 because it starts from rest, and then our t is 5 seconds. The distance moved is 4.5 meters, and finally we can use, we want to find acceleration. So based on these 4 parameters, we can use this equation, okay, this kinematics equation, as equals ut plus half at squared. So s equals half, okay, so s is 4.5, and then 1 over 2a, and then your t will be 5, okay, so squared. So cutting things short, a will be 4.5 divided by 0.5, okay, and then divided by 5 squared. That will be 0.36 meters per second squared. This is our acceleration of the block. Okay, so since we have the acceleration already, we can use F equals ma, okay, to get the frictional force. So based on the diagram, you can see that Fx will be the one which is pulling the block to the right, and the frictional force will be opposing it. Okay, so Fx minus frictional force equals ma. Alright, so Fx is, okay, so to get the horizontal component, you have to use cos, since adjacent over hypotenuse. So 6 cos theta minus our frictional force equals 3 times 0.36, okay, since our acceleration found to be 0.36 just now. So finally our frictional force will be 6 in bracket 24 over 25, okay, and then minus with 3 times 0.36, that will be 1.08. And finally our frictional force will be 6 times 24 over 25 minus answer, that will be 4.68 Newton, okay, and this will be the final answer for question number 6, part 1. For part 2, show that the coefficient of friction between the block and the plane is 0.165, correct to 3 significant figures. So since we already have our frictional force, okay, from part 1, we know that the formula for frictional force will be mu n, okay, but I use r in this situation, in this question, so it's mu r. So 4.68 equals mu r. So we need to find our r, okay, before we can find our coefficient of friction. Looking back at the diagram, you can see that r is in the same direction with Fy, and then both of them are in the opposite direction with the 30 Newton. So r plus Fy, okay, r plus Fy equals 30 Newton. So r equals 30 minus fy. So how to get fy? Looking back at the diagram, you can see that fy will be opposite over hypotenuse. So that means you have to use sine theta. That's why we find sine theta in the beginning of this question, in case we need to use it, right? So our fy will be 6 sine theta. So r equals 30 minus 6 sine theta. So sine theta is 7 over 25. So let's find what is our r. So 6 times 7 over 25, and then 30 minus answer, we will get 28.32 Newton for our reaction force. So here 28.32, so 4.68 divided by 28.32, we will get the coefficient of friction. So 4.68 divided by answer, we will get 0.165. Okay, it has been proven. Correct to 3 significant figures. And that will be the final answer for question number 6, part 2. And finally, for part 3, when the block has moved a distance of 4.5 meters, the force of magnitude 6 Newton is removed and the block then decelerates to rest. Find the total time for which the block is in motion. So total time means that it is from the start of this question, meaning that the block moves 4.5 meters in 5 seconds, plus the time it takes for the block to decelerate to rest. Okay, so after you found the time taken for the block to decelerate to rest, don't forget to add the 5 seconds. Okay, so now we need to find the final velocity of the block before the 6 Newton force is removed. Okay, so based on our part 1 just now, okay, for this one, we know that our u is 0. Okay, our a is 0.36, our t is 5 seconds. Okay, and then what is our v? Okay, this is what we want. So based on these 4 parameters, v equals u plus at is the formula that we can use. So v equals, this is 0, so a times t, 0.36 times 5, we will get 1.8 meters per second, okay, for the final velocity before the 6 Newton force is removed. Okay, so now after 6 Newton is removed, okay, we need to find the new acceleration. Okay, to find the new acceleration, please remember that, okay, the frictional force that we get in part 1, okay, if we have this Fy, okay, meaning that Fy has reduced the reaction force in this question part 1. However, in part 3, they said that the 6 Newton has been removed, meaning that you no longer have this Fy. Now you will only have your reaction force, okay, which is 30 Newton, equals to the 30 Newton. So we will have a new frictional force. So frictional force equals Ma. So frictional force is 0.165 times the new reaction force, which is 30 Newton, okay, without the Fy just now, equals 3A. So our A will be, so this will be 10, okay, because we cut with this 3. So it will be 1.65 meters per second squared for our new acceleration. Okay, so based on the V that we have, the A that we have, okay, we can find the total time. Okay, so I'm sorry, this is negative, okay, because this is a deceleration. I forgot to mention that, okay. So since we already have the deceleration, the velocity, okay, and also, okay, wait, this final velocity will be the initial velocity. Okay, I already mentioned this before. This final velocity before the 6 Newton is removed will be the new initial velocity. So 1.8 meters per second. And then our V, final velocity, will be 0 since we want this block to decelerate until it is at rest. And then our A is negative 1.65 meters per second squared. And we can find the time taken for it to decelerate to rest. So based on these 4 parameters, we can use V equals U plus AT. So 0 equals 1.8 minus 1.65T. Cutting things short, T will be equal to 1.8 divided by 1.65, we will get 1.09 seconds. Okay, so finally total time will be equal to 5 seconds plus 1.09 seconds. Okay, this 5 seconds is for the block to move 4.5 meters, and then 1.09 second will be the time taken for the block to decelerate, okay, until rest. So final answer will be 6.09 seconds.
Moving on to question number 4. The diagram shows a ring of mass 0.1 kilograms threaded on a fixed horizontal rod. The rod is rough and the coefficient of friction between the ring and the rod is 0.8. A force of magnitude T Newton acts on the ring in a direction at 30 degrees to the rod, downwards in the vertical plane containing the rod. Initially, the ring is at rest. For part A, find the greatest value of T for which the ring remains at rest. So for the ring to remain at rest, okay, your acceleration will be equal to 0. So before we can start this question, okay, it's better if we can list down all of the forces that we have in this question. So the x component, okay, of the T Newton here will be T cos 30 degrees. Acting upwards, you will have the normal force, okay, or the reaction force. Going down, you will have the weight of the ring. And to the left, okay, or to the back, you will have frictional force. And don't forget the y component, okay, of your T Newton here. That will be acting downwards, which is T sine 30 degrees. Okay, so FMA equals 0. So F equals MA. So your F will be equal to 0. You will have T cos 30 degrees minus your frictional force, okay, equals 0. So your T cos 30 degrees will be equal to your frictional force. So knowing that our frictional force is mu n, okay, mu n equals, okay, so this will be 0.8. This is the frictional force, 0.8 times your normal force. So as you can see, the normal force equals T sine 30 degrees plus W, and W will be 0.1 times 10, which is 1. So this will be 0.8 times 0.5T plus 1. And then finally, it will be 0.4T plus 0.8, okay, for your frictional force. So now, T cos 30 degrees equal 0.4T plus 0.8. So since we have T on the left hand side, so we shift this to the left hand side. So T in bracket cos 30 degrees minus 0.4 equals 0.8. And finally, your T will be equal to 0.8 divided by cos 30 degrees minus 0.4. Okay, so let's see what's the answer. You will get cos 30 degrees and then minus 0.4, 0.8 divided by answer. You will get a final answer of 1.72 Newton. Correct to 3 significant figures, and this will be the final answer for question number 4, part A. Next, for part B, find the acceleration of the ring when t equals 3. So when your t equals 3, okay, so we are going to use the same equation here, okay, t cos 30 minus frictional force. So t cos 30 degrees minus our frictional force will be, where is it? In bracket 0.4t, okay, and then plus 0.8 equals ma. Alright, so now t is 3, so 3 cos 30 degrees minus, okay, so 0.4 times 3, so that will be 1.2, 1.2, sorry, not 1.2, 0.4 times 3, right? Yeah, 1.2, 1.2 plus 0.8, that will be 2, equals your ma, your m will be 0.1, and then a. So now you will have 3 cos 30 degrees minus 2, you will get 0.598, so 0.598 equals 0.1a, and finally your a will be equal to, divided by 0.1, you will get a final answer, okay, which is 5.98 meters per second squared. Correct to 3 significant figures, and this will be the final answer for question number 4, part B. Now for question number 3, a particle of mass 2.5 kilograms is held in equilibrium on a rough plane inclined at 20 degrees to the horizontal by a force of magnitude T Newton, making an angle of 60 degrees with a line of greater slope of the plane. The coefficient of friction between the particle and the plane is 0.3. Find the greatest and least possible values of T. So the thing that you need to understand here is we have an equilibrium situation. So the thing that you need to consider for you to get the greatest or least possible values of T is to consider this, okay? So please listen. So we have this particle it's in a limiting friction, it's not limiting, okay, sorry. It's like this particle is about to go up the slope or about to go down the slope, okay? So we will have two cases, okay? So up slope or down the slope, okay? So this will determine, okay, whether we will get which one will get the greatest and which one we will get the least values for our T. So down the slope and up the slope, okay. So now before we start, let's draw our free body diagram. So we will have in this direction W cos 20 degrees, okay, or 25 cos 20, and going down the plane it will be W sine 20 degrees, okay. And for the tension, okay, or not the tension, okay, force T, okay, this will be T cos 60 degrees, and going this way will be T sine 60 degrees, okay. So as you can see now, we will have a force which will lift the W cos 20 degrees, okay. So this will affect our friction value later, okay. So now up the slope. So when we have it up the slope, so we can draw something like this, okay. So going up the slope, we will have T cos 60 degrees, okay. And since if we are going up the slope, okay, the friction will be acting downwards, okay, or down the slope. So friction will be acting down the slope, and the W sine 20 degrees will also act down the slope, okay. So W sine 20. So now we can have the equation of our FMA, okay. So T cos 60 degrees equals the frictional force, okay, and then plus W sine 20 degrees. Okay, so we know that cos 60 degrees is 0.5, so this will be 0.5 T equals, okay, so frictional force will be mu R, okay, some of you would call it mu N. So our mu has been given to be 0.3, and then our normal force will be determined later, okay, I will show you how. And then plus W sine 20, so our force, our weight is 25 because mass is 2.5 kilograms. So 25 sine 20 degrees. Make sure your calculator is in degrees, okay, so 8.551. So 8.551. So now we can find our normal force first, okay. So I think it's better if we do our down the slope later, down in this question, okay, below. So now we are going to do our normal force. So normal force will be equal to, okay, so if you look in the diagram, right, our normal force will be, okay, let me show you using maybe a blue color, okay. So this will be our normal force. So normal force will be in the same direction with T sine 60 degrees. So N plus T sine 60 degrees equals W cos 20. Okay, so since we want N, so N equals, okay, so W cos 20, that will be 25 cos 20 degrees, and that will be 23.49, okay, so 23.49 minus T sine 60, okay, so sine 60 degrees, that will be sec 3 over 2, okay, so sec 3 over 2 T, okay, let's just use the exact value. So now we are going to replace this inside our N. So 0.5 T equals 0.3 multiplied by this, okay, you will get 23.49. I think we shouldn't skip, okay, let's write first. 23.49 minus sec 3 over 2T, okay, and then plus 8.551. Okay, now we are going to expand. So 0.5T equals, okay, so 0.3 times 23.49, that will be 7.047, and then minus cert3 over 2, okay, not like this, cert3 over 2 times 0.3, you will get 0.2598 t, okay, don't forget the t, and then plus 8.551. So shifting your 0.2598 t to the left side, okay, so 0.2598 plus 0.5, you will get 0.7598 t. And then for the right hand side, you will have 7.047 plus 8.551, you will get 15.598. And then finally, your value of t will be equal to, so divide by 0.7598, you will get 20.5, okay, correct to 3 significant figures. So we don't know yet whether this will be the largest or the smallest possible value for our t. So let's just do down the slope for now, okay. So, okay, this one, we don't need to write it as the final answer yet. So now, down the slope, we are still going to have the same situation, okay, except now if you are going down the slope, your frictional force will be acting upwards, okay. So let's draw that. So we will have up the slope t cos 60 degrees, and then frictional force, okay, and then going down we will have w sine 20 degrees, okay. So all the values have been calculated, we just need to change the sign, okay, of the frictional force, that's all. So taking back from our previous equation, so we will get frictional force on the left side, so we will have 0.5 t, and then let's just take all the values from here, so 7.047 plus 7.047, and then minus 0.2598 t equals our w sine 20 degrees will be 8.551. Okay, so now 0.5 minus 0.2598, we will get 0.2402 t. And for our right hand side, okay, 7.047 we shift to the right, minus 7.047, we will get 1.504. And finally, our value of t will be equal to, divide by 0.2402, we will get 6.26 Newton. Okay, so as you can see, this will be the least value, least t will be equal to 6.26 Newton. Okay, final answer. And greatest t will be equal to 20.5 Newton. Okay, both answers correct to 3 significant figures, and this will be the final answer for question number 3. Now for question number 3. A block of mass 3 kilograms is at rest on a rough plane inclined at 60 degrees to the horizontal. A force of magnitude 15 Newton acting up a line of greater slope of the plane is just sufficient to prevent the block from sliding down the plane. For part 1, find the coefficient of friction between the block and the plane. So we have a force of magnitude 15 newtons acting up a line of greater slope. Okay, so that means, okay, we can say that it is pulling up 15 newton or pushing. Okay, it doesn't matter. Okay, so let's say 15 newton acting up the slope. So then, just sufficient to prevent the block from sliding down. Okay, so that is a very important statement there. Okay, when they said preventing the block from sliding down, so if the block is about to slide down, so that means, okay, your friction will be acting up the plane. Okay, so that is very important. So let's say that if the block is about to go up the plane, then your friction will be acting down the plane. So this is what they meant by prevent the block from sliding down the plane. Okay, they want to tell you, okay, implicitly the direction of the frictional force. Okay, so we know that frictional force, the formula will be mu n, okay, where n is the normal force, okay, or you can also call that the reaction force. All right, so now moving on to our FME, we know that the 50 Newton, okay, plus our frictional force, okay, will be equal to 0, okay, because our acceleration is 0, right? Okay, because the block is about to move, but it is not moving yet. And the forces going up will be equal to the forces going down the plane, okay? And the forces going down the plane will be mg sine theta, okay? Or some of you might call it w sine theta. So this will be mg sine theta. So 15 plus, okay, mu is the one that we need to find, okay, the coefficient of friction. And then the normal force, okay, or the reaction force will be this one, okay? So this is your mg cos theta, and your reaction force will be the opposite, okay? This will be your n. So your reaction force or your normal force will now be mg cos theta, so that means you will have 30, okay, cos 60 degrees equals, okay, and then 30 sine 60 degrees. Okay, so cos of 60 degrees, that will be half, so half of 30, that will be 15. So plus 15 mu equals, okay, so sine 60 degrees, that will be sec 3 over 2. So sec 3 over 2, so 15 sec 3. Okay, so then 15, okay, so you know that this is 15 plus 15. Okay, so let's just do like this, okay? 15 sec 3 minus 15. So mu will be equal to 15 sec 3 minus 15 over 15. And finally, giving our answer correct to three significant figures, okay? So 15 sec 3 minus 15, and then divided by 15, we will get a final answer of 0.732. Okay, so this will be the final answer for question number 3, part 1. The force of magnitude 15 Newton is now replaced by a force of magnitude x Newton acting up the line of greater slope. For part 2, find the greatest value of x for which the block does not move. So now for the second part of this question, okay, so since we have solved the part 1 of this question, so we can now replace our 15 with x, okay? So when they mention that the greatest value of x, that means not only, okay, so in this case, you can see that the frictional force is helping the x. So if you want the greatest value of x, you need to make the frictional force to be acting downwards, okay? Meaning against the force x. So now your FMA will be something like this, okay? So your x, okay, will be equal to, meaning now you are going against the frictional force. So x equals mg sine theta plus frictional force. So mg sine theta plus the frictional force. This is what we are going to have. So we already have everything, okay? Because we have the frictional force already. The frictional force is 15 mu. Okay, so the frictional force was okay. I think let's just do everything again. Okay, so 15 sec 3 is for the 30 sine 60 or the mg sine theta. So that will be this one, 15 sec 3 plus, okay, and then 0.732 times our normal force, and that will be 15. Okay, so finally our value of x will be equal to times 15 and then plus 15 sec 3, and that will be equal to 36.96, okay, or in three significant figures, that will be 37.0 Newton, okay? And this is a 2 marks question, okay? So that's why, okay, the working solution is very short. And this will be the final answer for question number 3, part 2. Now for question number 3. A string is attached to a block of mass 4 kilograms which rests in limiting equilibrium on a rough horizontal table. The string makes an angle of 24 degrees above the horizontal and the tension in the string is 30 newtons. For part A, draw a diagram showing all the forces acting on the block. Okay, so a block, okay, and then we know that the tension in the string, okay, makes an angle of 24 degrees to the horizontal. So let's say this is the horizontal. So this will be the 30 Newton tension in the string, and this will be the 24-degree angle. Okay, and then since we are having this block on a rough horizontal table, so this will be your frictional force, and the mass of the block is 4 kilograms, so that means the weight will be 4 times 10, which is 40 Newton. And then we will have another force which is going up we can call that reaction force, or we can also call that normal force. So let's call it reaction force, okay? R Newton. So this will be all the forces that we have for this question, and this will be the final answer for question number 3, part A. And finally, for part B, find the coefficient of friction between the block and the table. Okay, so for part B, please remember that we have limiting equilibrium, what we call it, condition for this block. So that means the forces in the x direction must be equal to 0, and the forces in the y direction will be equal to 0 as well. So we can start with finding the reaction force, okay, that we have in this question. So that means we will have to do the summation of forces in the y direction to be equal to 0. Okay, so summation of forces in the y direction to be equal to 0. So then you can see that R, together with the vertical component of this 30 Newton, will be equal to 40 Newton. So we can write that. So R plus, so the vertical component will be 30 sine 24 degrees, okay, to be equal to the force going downward, which is 40 Newton. So then your R will be equal to 40 minus 30 sine of 24 degrees, and that will be equal to 27.8 Newton. Okay, so this will be our reaction force. Okay, so what can we do with our reaction force? We can find the frictional force that is acting. Okay, so we know that frictional force equals mu, okay, and then R. So then if we have our frictional force, we can find what is our coefficient of friction between the block and the table. Okay, so now using force in the x direction, resultant of forces in the x direction to be equal to 0, and we only have two forces, which are 30 cos 24 and the frictional force. So then it will be 30 cos of 24 degrees to be equal to the frictional force. So then you will have 30 cos 24 degrees, that will be 27.4 Newton, equals, okay, our mu is unknown, but our R, the reaction force, will be 27.8. So straight away, our mu will be equal to 27.4 divided by 27.8, and then we will get a final answer of 0.986, correct to 3 significant figures, and this will be the final answer for question number 3, part B. Let's look at question number 6. A block of mass 5 kilograms is placed on a plane inclined at 30 degrees to the horizontal. The coefficient of friction between the block and the plane is mu. For part A, when a force of magnitude 40 Newton is applied to the block, acting up the plane parallel to a line of greater slope, the block begins to slide up the plane. Show that mu must be less than 1 over 5 serd 3. Now, the first thing that we need to do is we need to label all the forces that we will have on the diagram. So going down the plane will be frictional force, because they mentioned that the block is about to slide up the plane, so frictional force will be acting down the plane. And another one will be the weight, okay, component of the weight of the block, okay, which is going down the plane, and that will be 50 sine 30 degrees. And then going into the plane will be 50 cos 30 degrees. And we will also have going out of the plane, which is the reaction force. Okay, so now since they mentioned that the block is about to slide up the plane, okay, we know that our acceleration will be equal to 0, okay, and our summation of forces will be equal to 0 as well. And if it is about to slide up the plane, we need to consider our summation of forces to be bigger than or equals to 0, because if it is less than, then it will not be about to slide up the plane. Okay, so that's why we have to consider more than, okay, or equals to in this case. Okay, all right, now what we can do is we know that for the component which is perpendicular to the plane, we will have our R to be equal to 50 cos 30 degrees, and this will be equal to 25 serd 3. Okay, so we are going to use this when we are finding the frictional force later. Okay, so now for the parallel to the plane, we will have 40 Newton, okay, to be okay, yeah, by the way, I forgot, we have to make this this one, okay, what I mean is going up the plane, okay, must be bigger than or equal to 0. Okay, that's the thing. So now what we can do is 40 minus frictional force minus 50 sine 30 degrees must be bigger than or equals to 0. This is the case, okay? So now, our frictional force is mu r, so we can change that into mu multiplied by your r, which is 25 sert 3. And then sine 30 degrees, that will be half. So 50 times half, that will be 25. So minus 25 to be bigger than or equals to 0. So we can shift everything else other than the mu, okay, to the right hand side. So leaving the mu on the left hand side. So now we will have negative, oh yeah, by the way, I forgot, we can factorize out our 25 later, okay? But I think we don't have to do that yet. So negative 25 sert 3 to be bigger than or equals to 25 minus 40, that will be negative 15, okay? And then, oh yeah, mu, by the way. So sert 3 mu, okay, so since you remove this negative, okay, you will have less than or equals to 15 over 25, that will be 3 over 5. And finally, mu, okay, must be less than or equals to 3 over 5. Okay, when you divide by sert 3, we will have sert 3 over 5, okay, which is essentially 1 over 5 sert 3. Okay, so in the question, they mention only less than, okay, not less than or equals to. So why is that? Okay, the reason is simple, because if it is equal to 1 over 5 sert 3, that means it is going to, it will not move. So since we want it to begin to move, okay, so that means we cannot equate that to 1 over 5 sert 3, okay, so that is the explanation. So we still get the correct value here. So finally, our mu will be less than 1 over 5 sert 3. Since, okay, you can explain a little bit, since when mu equals 1 over 5 sert 3, it is still not moving, okay? That is the thing. So we need something which is less than this, okay? So this will be the final answer for question number 6, part 8. And for part B, when a force of magnitude 40 Newton is applied horizontally in a vertical plane containing a line of greater slope, the block does not move. Show that, correct to 3 decimal places, the least possible value of mu is 0.152. Now for part B, we will have still the same diagram, but with a little bit of adjustment. So we will have still the 30 degrees here, and then the 5 kilogram block, okay? But now we will have a 40 Newton force horizontally, okay, acting horizontally to the block, okay, and then, okay, nothing else. So now what we need to do is, we need to give the forces that is not indicated in the diagram. So this will be 50 sine 30 degrees, which is parallel to the plane. Going into the plane, you will have two forces, okay? The first force is the component of the weight into the plane, which is 50 cos 30 degrees. And the other one will be the component of the 40 Newton here, which is into the plane, and that will be 40 sine 30 degrees, okay? And then going up the plane, you will have 40 cos 30 degrees. So now what we need, okay, is the direction of the frictional force, okay, because they just mentioned that the block does not move, okay, that's the thing. So now we need to find what is our R first. Oh yeah, another thing is I forgot to label the R. So the R that we have here will be equal to 50 cos 30 degrees and then plus 40 sine 30 degrees. So this will be equal to 50 cos 30 and then plus 40 sine 30 degrees. We will get 63.3, okay, Newton. Yeah, because this is force, right? So now for the block to not move, okay, so this is the thing. We can put our acceleration equals 0. So our force, okay, summation of forces to be equal to 0 as well. Okay, so we have two cases, okay. If the block does not move, okay, it may mean that the 40 cos 30 degrees will be bigger than, or not bigger, okay, if the frictional force is acting down the plane, then the 40 cos 30 degrees will be what we call it, equals to the forces going down the plane, or okay, because you can see that the only driving force here is your 40 cos 30 degrees, right? Okay, that's the thing. That's the first thing that you should understand. So the block will go down, okay, due to the 50 sine 30 degrees, okay? Okay, so I think it's better if I just show you the calculation. Okay, that would be easier. Okay, so if we have like the frictional force going up the plane first, okay, up the plane, meaning that the forces which is going up and going down, we need to calculate first what is the value, okay, and see whether it is possible or not for the frictional force going up the plane. So you can see that 50 sine 30 degrees, that will be 25, right? Okay, so going down the plane will be 25, and 40 cos 30 degrees will be 34.64. Okay, so we know that for a frictional force to be going up the plane, the forces going down the plane must be bigger. But since your forces going up the plane is always bigger than the forces going down the plane, okay, so your frictional force is only possible to be going down the plane. That's the explanation. Okay, all right. So frictional force going down the plane. So then what we are going to do now is we will, okay, so going down the plane is this way. So it will be 40 cos 30 degrees, okay? And then what we call it, oh yeah, by the way, we have to establish something else first. For it not to be moving, okay, let's say we establish F to be equals to going up minus going down. So 40 cos 30 degrees minus frictional force, and then minus 50 sine 30 degrees. We want this force, okay, to be less than or equals to 0. Okay, how should I say this? If it is bigger than 0, that means it will be going up the plane. That's the thing. Okay, so if it is less than 0, that means it will not be going up the plane. It will not move. Okay, so now we will have 40 cos 30 degrees minus 63.3. I forgot to put this, what we call it. Oh yeah, I forgot to mention that this is just the R, okay? For the frictional force, we have to put the mu. And then minus this is 25 to be less than or equals to 0. So then we will have, okay, negative 63.3 mu to be less than or equals to 25, okay, minus 40 cos 30 degrees, okay, 34.64. So then we will have negative 63.3 mu to be less than or equals to, as you can see, this will be negative 9.641. And then remember that if you remove the negative from the mu, you are going to shift, okay, the arrow. So it will be mu 9.641 divided by 63.3. And we will have a final answer of, as you can see, we have what we call it at least, right? So the answer, we negative it, so it becomes positive. So divide by 63.3, we will get 0.152. Okay, correct to 3 significant figures. Okay, so like I said, we won't have any case of the frictional force going up the plane, because our force going up the plane, the driving force here from the 40 Newton, is already bigger than the 50 sine 30 degrees. Okay, that's the thing. So our frictional force can only be acting down the plane. Okay, so this will be the final answer for question number 6, part B. Question number 1. A small ring P of mass 0.03 kg is threaded on a rough vertical rod. A light inextensible string is attached to the ring and is pulled upwards at an angle of 15 degrees to the horizontal. The tension in the string is 2.5 Newton. The ring is in limiting equilibrium, and on the point of sliding up the rod, find the coefficient of friction between the ring and the rod. Okay, so the first thing that you should be looking at is the ring is in limiting equilibrium. Okay, meaning that the forces in the x and y direction, okay, will be equal. Okay, or the resultant force, okay, will be 0. And if it is at the point of sliding up, okay, and remember that this is a rough vertical rod. So if it is at the point of sliding up, that means the friction will be acting downwards. Okay, so that is the thing that you need to understand. All right, so now what we can do is to list down all the forces that they didn't give us. Okay, so the first one will be the weight, okay, of the ring, which is 0.03 multiplied by 10, so that will be 0.3 Newton. And then, as I mentioned just now, okay, the friction force will be also acting downwards since the ring is at the point of sliding up the plane. Okay, and then since our 2.5 Newton has component, okay, so we will write upwards as Okay, so you can see that this is upward, right? So opposite, that means you are going to use 2.5 sine of 15 degrees. And also you will have a force going to the right, okay, and that will be 2.5 cos of 15 degrees. And since you have force to the right, then you will have a normal force, or you can also call that a reaction force to the left. Okay, so now the first thing that you should do is let's solve for the vertical component. So that means you will have, okay, so let's write resultant force in the vertical component. Okay, so sigma Fy, okay, or summation of forces in the y direction, okay, or the vertical component will be equal to 0. So then it will be 2.5 sine of 15 degrees equal our weight, which is 0.3 Newton plus the frictional force. Okay, so then the frictional force will be equal to, so you are going to shift this to the other side. So 2.5 sine of 15 degrees minus 0.3, and you will get 0.347 Newton for your frictional force, okay? And then you know that frictional force will be equal to mu n, or some of you will call it mu r, okay? Which is for normal force or reaction force. And we have the normal force to be equal to 2.5 cos 15 degrees. So then it will be 0.347 equals mu, which is the coefficient of friction, and then 2.5 cos of 15 degrees. So straight away, our mu will be equal to, so divided by 2.5 cos of 15 degrees, and that will be 0.144, correct to 3 significant figures for the final answer for your value of mu. And this will be the final answer for question number 1.